day, students. Today we are looking at simple machine. Last time we looked at work, energy, and power, which we have concluded. But today we are looking at simple machine. Our lesson objectives at the end of the lesson, students should be able to, one, define a machine and list at least 5 simple machines that you know. Then second one, you must be able to define the first, that's force ratio, which can also be called mechanical advantage. Then you have to be able to define velocity ratio. Then you have to be able to define efficiency and write down mathematical relationship between them. Then the last objective, you should be able to calculate force ratio, which is the mechanical advantage, then velocity ratio and efficiency of a machine. So what's a machine? Definition of a machine. Now, to a layman defines machines to be a device that makes your work easier to do. But in physics, we define machine to be a device that makes use of small effort to overcome a large load at another point. And examples of these machines, we have simple machines. We have the lever, we have the pulleys, we have the pliers, we have the wheelbarrow, and the inclined plane. Look at the one I have with me here. This is scissors, and it is also a simple machine. Now let us look at the definition of this, the force ratio, the velocity ratio, and the efficiency. Don't forget I said force ratio is also mechanical advantage. Then velocity ratio, then we have efficiency. So what is the definition of force ratio, which is mechanical advantage? Force ratio is actually defined as the ratio of the load to the effort. As the ratio of the load to the effort. That is, if you know your load and you know your effort, by the time you put your load as your numerator and your effort as your denominator, you are going to have what we call force ratio, which is also mechanical advantage. Then we also have velocity ratio. What is velocity ratio? This is the ratio of the distance moved by the effort to the distance moved by the load. That is effort distance over load distance. That is distance moved by the effort then to the distance moved by the load. Then what of efficiency? Efficiency is also defined, can define efficiency as the ratio of mechanical advantage to the velocity ratio expressed in percentage. This is the formula for efficiency. Or you can also use work output over work input times 100%. The unit of efficiency is 100%. So you know what efficiency means when you say a machine is not that efficient. It means that the ratio of the work output to work input expressed in percentage is very small. Then let's look at this question, a problem of simple machine. Let us solve this question together. Now, using wheel and axle machine, a load of 400 Newton, the first thing to do in physics is to write out your parameters. So a load of 400 Newton can be applying a force of 80 Newton. That is your effort. Applying, that's the effort you are applying. That is 80 Newton. Then the radius of the wheel, that is the radius of the wheel, is equal to 32 centimeter. The radius of the axle is given as 4 centimeter. Now to do this now, the first question says force ratio. I told you force ratio is mechanical advantage, which is load over effort. So it means 400 over 80, which is going to give you 5. Of course, it has no unit because the unit of load is in Newton, is a force, and effort is also in Newton, which is a force. Then the second one, look at the second question. You have to find the velocity ratio. Velocity ratio for wheel and axle machine is calculated by the radius of the wheel over radius of the axle. The radius of the wheel is given as 32. The radius of the axle is 4, and that is 8. It doesn't have unit also. Why? Because radius of the wheel is measured in centimeter, radius of the axle is in centimeter. So then, the last question here is the efficiency. Efficiency is equal to MA, which is mechanical advantage, over velocity ratio times 100%, which means MA, which you have gotten, which is 5, velocity ratio, which is 8, times 100%, and that's 500 over 8. 8 in 50, that's 6, remainder 2. 8 in 20, that's 2 again. Remainder 4. 8 in 40, that's 5. Then the unit is percentage. That means the machine is 62.5%. Now in Google Classroom, we are going to be looking at the other velocity ratio for other simple machines that we have, like inclined plane is 1 over sin theta, and some other ones like the lever is effort distance to the load distance. When we get to the Google Classroom, we'll do more of this. Thank you.